Hi everybody. So, welcome to our video on exercise 4. So once again, I'm sorry I'm not in class. Now, the biggest thing about exercise 4 is it's important that you're recognizing patterns. Patterns between each number for all these sets. So looking at examples B and C, looking at example B, I'm definitely confident that you guys can do that one. C, I'm sure some of you can figure out this pattern. But exercise A is the one I'm going to work with you today because this pattern is neither arithmetic or geometric. So looking at exercise A, or A, we are given 9 plus 16 plus 25 plus ... plus 100. So this ... means that the pattern is continuing. Pattern continues. And it's continuing all the way through. Looking at that ... that's going to put everything else in the pattern. So let's say I had 1, 2, 3, ... 8. This ... if I continue the pattern, I'm increasing by 1. It's 1, 2, 3, 4, 5, 6, 7, 8. All the numbers in between continuing the pattern. That's what that tells you. So, I have this ... I'm continuing the pattern that I see there. Now, this is not just a sequence. This is a series. A series is the list of the terms. A sequence is the list of the terms. A series is the sum. So when you see the word sequence, I want you to think list. When you see the word series, I want you to think sum every single time. Looking at this series, we need to determine what this pattern is. So I'm looking at this pattern, I see it right away. I know these are all perfect squares because 9 is 3 squared. 16 is 4 squared. 25 is 5 squared. And I know this pattern continues, and that 100 is 10 squared. These are one of those things you just have to know and looking at patterns. That's why we did a lot of pattern recognition in the first 2 lessons. So looking at this pattern now, these are my values of n, the inputs, and in black I have the output of the series. So what I want to do is I want to write each of these sums using sigma notation. So I know first I need to find the equation of this sequence. So if I'm squaring all my numbers every time, I know that a sub n, the series sequence itself, is going to be n squared. Because I'm taking whatever value I plug in for n and I'm squaring it. Now what we need to do is we need to write the sum, or the series, for this sequence. So I'm going to look at the term number I'm starting at. Say I have my sequence. Let's say I have I equals wherever I'm starting, and I'm going to use I this time, so I squared. If I'm trying to sum I squared instead of n, I need to know, equal sign. I need to know where I'm starting from. Now this letter could be anything you want. It could be I, it could be K, whatever. If I look at the value of it and I'm starting from 3. And I'm going to keep going until I get to 10. Because the first output is 9, and that was 3 squared. So I'm just going to sum from 3 all the way up until my highest value, which was 10 of my input. So right here is exactly what we're looking for, working backwards. So I want you to pause this video now and take any notes that you need. The next 2 examples, they're both either, one's arithmetic and one is geometric, so you should be able to figure out the pattern right away. Step 1 is develop the formula for the sequence. After you get your formula for your sequence, you're going to create a sum with a summation. If you have any questions, feel free to email me. I'm not making a video for exercise 6. I will go over that in class when I see you guys tomorrow. You're expected to complete exercises 3, 4, and 5 on the back of this, as well as the homework assignment that you're going to get from Mr. Papadopoulos today.